Hello! In the last video, we looked at some phenomena about atoms and light. We looked at flame tests, and we looked at neon lights, gas discharge tubes, and we saw that elements always emit the same color, which is actually a combination of colors called an emission spectrum, when they're excited, when they're given energy. And we asked the question, why does that happen? Why those specific colors? And will there be any other color that could be emitted? This is a simulation made by Fett from the University of Colorado that shows us Niels Bohr's model of the atom and the attempt by Niels Bohr to explain these phenomena. So let's take a look and see what happens. So we'll click play, and you can see in the middle we have a nucleus made of a proton, that's the red dot, and going around the nucleus is a blue electron. And that electron is just going around and around on that circle. And you can see that there are lots of different circles. These are called energy levels. And on the right over here, we have kind of a graph of which energy level the electron is at now. So right now the electron is at level 1, but it could be at level 2, level 3, level 4, 5, 6. And down here, this is the spectrometer. When this atom emits light, it will show up on that graph at the different color. So let's turn on the light and we'll see what happens. I'm just going to let this go so we can watch for a minute. So let's talk a little bit about what's going on. First thing, what are these particles coming up, moving from the bottom to the top of the screen? These are called photons. They're light particles, and they're different colors to represent all the different colors of light that make up white light. So you can see that sometimes when a photon hits the electron, it moves to a higher energy level. So now it's on level 1, now it jumps, and now it's on level 4, now 3, now back to 1. Now 2, now 1. Now 4, back to 2, back to 1. Okay. So the electron is jumping around between energy levels when it hits a photon. But that's not the only thing that happens. Let's see. So there's level 3, back to 1, level 2, level 1. All right, did you notice the blue photon? It's hard to see and I can't go back, but I'm going to see if I can slow this down. Okay, this photon right here, this one, right? That wasn't there before. It was created by the electron. Let's see if we can find that again. You can see it's moving in a different direction than the others. So the electron's on level 1. Still on level 1. Oh, now we're on level 5. Okay, this photon right here. Did you see that one being created? When the electron fell back down to level 1, this photon was created and it's going in a different direction. There's level 6. See if we can watch this happen again. Okay, I think that was this photon, right? This purple photon, this arrow up here, also purple. That's interesting. And we've got a purple or a dark blue dot on our spectrometer. So when the electron falls down to a lower energy level, it's creating a new photon of a certain color, and that photon is being graphed down here. So that's the short version of what's going on. We'll look at more details in the next video. See what else you can figure out on your own. Pay attention to the different colors. There's purple. It may also help to look at the energy level diagram. There's red. I'm going to speed this up. Let's see what colors we can see. Red, light blue, red, light blue, red, red, red. Do you notice anything about the colors? What do you notice? Red. So this is the simulation of the Bohr model of the atom and how it explains emission spectra. We'll go into more details in the next video. Thanks for watching.